Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 64 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are running on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do today is I'm going to teach you the fundamentals of Python in one session. So this lesson might be an hour or something like that. But what I'm going to do is I'm going to sort of take you through and show you the really important fundamentals of Python. Now, why am I doing this in an Arduino class? Because we're to the point in Arduino that we want to connect our Arduino to Wi-Fi, and we want to control our Arduino, control our project, or get data from our project on our desktop computer. So we will connect to it over Wi-Fi. We have to have something running on the desktop. What we will have running on the desktop is a Python program. Now, in future lessons, I'll show you how you can build GUIs, graphical user interfaces, where you can display data coming from the Arduino, and you can control various aspects of the Arduino from your graphical user interface. So last week, we installed Thonny, which is a very nice IDE for Python. If you haven't installed Thonny already, go back to lesson number 63, go back to last week's lesson, and then you'll be ready to jump in right with where we are today. Now, what we are going to do now is we're going to go ahead, and I'll get out of your way. I have a sip of my coffee, and then I need you to open up a fresh new Thonny. Okay, so now what are we going to do? We're going to learn Python. The best way I can introduce you to Python is to kind of show you the things that are similar to the Arduino C language and then show you where the differences are. So in Arduino, we worked with variables, we worked with arrays, we worked with conditionals, that would be like if statements, we worked with compound conditionals, we worked with for loops, we worked with while loops, we did all of those types of things. Well, those same fundamentals we will be doing in Python, but the syntax of how to do a for loop or how to do an if statement are different. So the fundamental function is the same, but the syntax when you're programming is different. But since you've been through all of that already in Arduino, it should be pretty easy to pick up and become comfortable with on Python. Now, there are two very fundamental differences between Python and Arduino. The first is Arduino is a compiled language. The C language on Arduino is a compiled language. What does that mean? In our IDE, we write our program, then we press the little go button on the IDE, and then our PC goes through and compiles that entire program in the IDE. What does it mean to compile a program? It's to take the nice English words and the nice logical commands and to translate those into machine code, which is just a series of zeros and ones. So while we're in the IDE, Every line of code, that whole program is converted into a string of zeros and ones. Then on the Arduino IDE where it says downloading, now it's taking that long string of zeros and ones and it is pushing it down into the Arduino. So now the Arduino has the program, but the program has just become a series of zeros and ones. The program compiles one time, and that's when we press the go button on the IDE. It compiles, it downloads. Then after that on the Arduino, if you unplug and plug the Arduino back in, it'll run that program again, but it doesn't have to compile it again. If you hit the little reset button on the Arduino, it runs the program again, but it doesn't have to compile it again. And because of this, since it's a compile once and run many times language, it is very, very, very fast. Now, Python is different. Python is not a compiled language. It is an interpreted language. So if I have 4 lines of code, 1, 2, 3, 4, when I press the run button for Python, it looks at the first line of code, it changes it into machine language, and then it executes that little snippet, that little line. Then it goes to the next line. It compiles it, and then it runs it, goes to the next line. It compiles that line, runs that line. So it's for each line of code, compile, run, compile, run, compile, run. Now, the second time I run the program, it does the whole thing again. Every single line of code is compiled again, and every single line of code is run again. So what's the difference between those two? The first is that C on Arduino is blindingly fast because the time to run the program is the time to compile it. To actually execute it is very quick. So on Arduino, you compile once and then it executes or it runs very quickly. On Python, you have to compile every line every time, so Python runs much slower. Now, what's the advantage of Python? Because it is an interpreted language, it tends to be a lot more user-friendly and a lot more intuitive to use. And so it's a little bit easier to use. The downside is it's slower, okay? I hope that makes sense. All right, so now let's come in here and let's see if I can just sort of start introducing you to Python. So part of this being an interpreted language is that it is command ready. It is command ready, which means it's sitting there. And if you give it a line of code, don't even write a program, just give it a line of code, it'll compile and execute that line of code. So if we were going to write a program, we would be up here writing the program and then we would run it. But because Python is execution ready, we could come down here and we could put in a line of code at the command line and then it would run it. So what I could do is I could say here print, and then I'm going to print the string hello world like that, and then boom, it compiles and executes that line of code and we get a friendly greeting of hello world. Now, notice also to do the print, we didn't have to turn on the serial monitor. We didn't have to set a baud rate. We didn't have to do a serial.println. It's just very intuitive. It's just like print hello world, or I could say, print 7 like that, okay? And it prints a 7. Or I could say x is equal to 7, and then I could say print x, and then it prints 7. Now, something else that you notice in what I just did, I said x equals 7, and I didn't have to declare the variable. I didn't have to say it was an int. I didn't have to say that it was a float. I didn't have to say it was a string. It's just Python looked at it and said 7. Well, that's usually a number. And he didn't put a decimal point on it. So he probably wants it to be an int. So it kind of figured it out. But if I say x is equal to 7.0, and then I say print x like that, it makes it 7.0. It made it a float, okay? So you don't have to declare your variables. That makes programming easier, but it also makes it easy to introduce errors that are catastrophic and very hard to find, because in your mind, this variable is a certain type, but Python did something unexpected and it makes it a different type. And then all of a sudden you can get some very unusual and very difficult problems. So basically, I would sort of say it this way, that Python gives you enough rope that you can hang yourself. Like on Arduino, if you don't say, hey, X is an int and X is 7, and you just say X is 7 without saying beforehand it's an int, it won't compile. It'll give you a problem like, hey, buddy, let's get our variable straight before we move on. Okay, so let's say, again, I'm going to just say X is 7, all right? And then I could say print X, like I've been doing, and get a 7, but it goes a little quicker. You don't actually even have to put in the print at the command line. If I just say X, it'll give me the value of X. And I'm going to start doing it this way so that we can move a little bit back faster. Okay, so I'm going to say X is equal to 7. I'm going to say Y is equal to 2, and then I'm going to say Z is equal to X plus Y. And then I'm going to say print, or I'm just going to say Z, right? I'm going to stop saying print Z. I'm just going to say Z. And look at that. Z is 9. And what it thought is, well, X is an integer, Y is an integer, and Z is X plus Y. It would make sense for Z to be an integer. But what if I say X is equal to 7, and I say Y is equal to 2.5, and then I say Z, or 2.7, let's say, Z is equal to X plus Y, and then I'm going to look at Z, and look at this. X was an integer. I add 2.7, which is a float, so I'm adding a float to an integer, and say, well, X is an integer, Y is a float, and really probably the answer might be a float, so I better make Z a float. So it decided to make Z a float. Okay, I didn't tell it to do that. That's what it decided. Well, it sort of makes sense to make Z a float, but you got to remember, sometimes you can get surprised. Okay, you can also have strings. I could say my car is equal to, in a quote, Toyota. Okay, and then I say, what is my car? My car is Toyota. Now you can also use double quotes. Now in Arduino, a single quote is only for a single character. If you're going to do a string, you've got to do the double quote. But in Python, the single quote and the double quote are interchangeable. You see, I could say my car is equal to a Ford. I can't do that. My car is equal to a, what do I like besides a Toyota? Let's say a Jaguar, like that with double quotes. And then I say my car. And look at that. Even though I used double quotes, it accepted it, but it seems like maybe it prefers to use single quotes for strings. Okay. So we set it, we set it to a string, and so that kind of makes sense. You might think, wow, I don't have to declare my variables, but you've really got to be very, very careful, because a lot of times we get in trouble with the way these things work. All right, so we have done integers, we have done floats, and we have done strings. Well, what we also need sometime are arrays. Okay, we need arrays. And so an array would be a variable that has more than one value. So I could say X, and I could say X is equal to open square bracket 5, 4, 3, 2, 1, 2, 1, like that, and now I'm going to close that, and it like that. Now I say, what is X? X is the array 5, 4, 3, 2, 1. Now, if I said, show me X of 1, that's the X index 1. That's not saying show me this one value. It's saying show me the 1, the first position in the X array. What would you predict? And leave a comment down below or put it in the live chat. What would you expect if I said X is 1? What is it going to show when I hit enter? And if you said 5, you would be wrong because the arrays are indexed starting at 0. So this is the 0th element. This is the 1 element, the 2, the 3, and the 4th element. So remember that it starts counting at 0. So the 1, the first element, the 1 element is the 4, and the 5 is the 0 element. Okay, well, what I could also do is I could come in and say X of 4, that would be 0, 1, 2, 3, 4. X of 4 can be equal to 25, and it seems to have taken that. And now if I look at X, this number that was a 1, the 4th element has become 25. So you can see that I can modify my arrays using these simple equals commands. All right, well, what if I wanted to add one? What if I want to say X of 6 is going to be equal to, let's say, 100. Uh-oh, error. Line 1 in module, index error, list assignment index out of range. What does that mean? When I created it, I put 0, 1, 2, 3, 4. This is an index of 4, a total of 5 items indexed up to 4. And so when I try to index 6, I get an out of range error because there is no 6th element. There is a 4th element. And likewise, I think if we tried to do X of 5 is equal to 100, we get an error. X of 4 should be back in the range, and that it took. And everybody's happy. But what if I want to add something to the list? What I got to do is I got to avoid that out of range error by saying take my X array and dot append to it. And what do I want to append to it? Now notice the smooth parentheses, not the square bracket. I want to append a 25 like that, 25. And now if I look at X, what do I get? I get what I had before, and then I have appended a 25 to it. And now if I did X of 5, it's, oops, what was that? Why did that not like that? Okay, now if I do, I don't know what just happened there, but if I do X of 5, what I get is 25. That's good. I could also say X of 5 now is equal to 30, and then X, and you see it changed it. So you can't add something beyond the present length of the array, but you can dot append, and you can add things that way. But I couldn't just come in and set X of 7. What I would have to do is I would have to append the 6th element and then append the 7th element. And so that is the way that works there. Okay, now also what I could do is I could say something like my fruits are going to be equal to an apple, an orange, and a banana. Banana. Like that. Okay, and close it. Now, what are my fruits? My fruits are apple, orange, banana. Now, what is my fruits of 1 would be orange. Okay, so that's kind of interesting there. Now look at this. What if I said, give me my fruits of 1, and then also after that of 2? You guys predict what this is going to give me. I said, give me my fruits of 1 and 2, like that. What do you think is going to happen? Leave a comment in the chat. What's going to happen? All right. Now, what it does is it's thinking, well, my fruits of 1 is orange, and now he wants to index orange to the 2 element, and this would be the 0 element, the 1 element, and the 2 element. So he just decided to say, well, I got to do something. Maybe he wants me to bust that first element, orange, up into letters and then give me the 0, 1, 2 position letter, which would be an A. So you see how Python just, it's almost like it just is trying to figure out what you want it to do. Okay. Now the other thing that's kind of interesting is I could say random stuff is going to be equal to 5, which is an integer. Okay, 5, which is an integer, 3.14, which is a float, and then grapes, which is a string. Okay, now what if I say random stuff? I get 5, 3.14 in grapes. What if I say random stuff of 2? What do I get? I get grapes. Now, watch this. Watch this. Okay, watch this. I'm going to create an array, my array, and that is going to be 1. It is going to be 2.5. So I've got an integer, I've got a float, and then I'm going to put a mango. And then what I'm going to put is open a list. I'm going to put an array, and that array is going to be 5, 4, 3, 2, 1. And then I'm going to close the array, and then I'm going to close my array. And I should have put an equal sign in here like that. Okay, hopefully that makes sense. So you see how flexible, like, man, in C on Arduino, it's just like your arrays have to be super clean. Here it's like whatever you want to put in there, Python's okay. Okay, you want to mix floats and integers and strings and arrays. Yeah, you can do that. So let's look, my array. Boom, it's what I wanted. What is my array of 0? Like that, it's a 1. What is my array of 2? It's mango. What is my array of 2? 1. That is going to be the letter A. So it is 0, 1, 2, okay? And then it is 0, 1, and it gives me the A. Now here's where it gets pretty interesting. I'm going to say my array, okay, and then I'm going to say my array 0, 1, 2, 3, my array of 3, and then what do I get? I get an array. Well, now I could say my array of 3 and 2. What do you think it's going to give me? 0, 1, 2, 3. It's going to give me this whole thing, and then it's going to give me 0, 1, 2. It should give me a 3. Boom. Okay. Now, what you could also do is you could say my matrix is going to be equal to, I'm going to open it, and then the first element is going to be 1, 2, 3. I'm going to close that array and put a comma, and then I am going to have 1, 2, 3, and then I'm going to have 4, 5, 6. I'm going to close that, and then I'm going to have 7, 8, 9 with commas. Okay, now I'm going to close that element, and then I'm going to close the overall array. Okay, so my matrix of 1 kind of gives you the first row. My matrix of 2, it gives you the second row. And then my matrix of 3 gives you the third. Ooh. Oh, I'm sorry, I should have started with 0. My mistake. Let's try that again. 0, is the first row. I'm hitting the up key to get things to pop back up quickly if you wonder how that magic is happening. 1, okay, and then I get my matrix of 2, okay. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I could hit my up key to make it easier, 2, and then go to the 1th element of the second row, and then I get what? 8, which would be that number right there. Okay, is that making sense? Now, I'll just do one more. If you think of a picture has RGB, okay? Each pixel has RGB, all right? Each pixel has RGB. And so let's see if I can come back up here, okay? And then what I want is, so I have 3 columns and 3 rows. And so I have 1, 2, 3, 4, 5, 6, 7, 8, 9 pixels. But I could give each one of these a color. Okay, I could get each one of these a color. So this could be like 255, 0, 0. And what would that be? That would be red. And then this one would be 0, 255, 0. That would be green. And then this one would be 0, 0, 255, like that. And then you see what I could do is I could be building colors. You see, I could be building colors. And let's see if that works. I don't know if I balanced everything. Let's see. Maybe I need to close again. I think I've gotten my, okay, let's look at my matrix. Okay, so you see I've got the color red, I've got the color green, I've got the color blue, and that is the first row. This is pixel 1, 2, 3. And then I didn't go ahead and do different colors for pixel 4, 5, 6, 7, 8, 9, just because it's a lot of typing. But you can see that you can just have these nested lists or nested arrays. And so a 2 by 2 matrix within each point having 3 numbers associated with. Then I could say like my matrix, and I want to go to the 0th element, which is the first row. And then I want to go to the first element, or let's go to the 0th element in that. And what is that going to be? That's going to be 255, 0. If I wanted to dial all the way into red, like what is the value of red? I would come in and put 0, 0, 0, and then that should give me the 255. Sometimes I don't know what I hit. Maybe I'm hitting page up. Okay, so there's the 255. Boom. Okay. Now, you've seen, we haven't written a program yet. We're just sitting here playing with the command line, playing with the interpreter one line at a time. But now let's see if we can write a program. So we're going to come up here to the program. And what I'm going to say is I am going to say print. I'm going to say hello world. Now look how friendly that is. Notice that I didn't have to start the serial monitor. I didn't have to set the baud rate. I didn't have to do a serial.print or serial.print line. I just said serial print. And now what we need to do is we need to save this. So I am going to save as, and somewhere you have a Python folder. If you don't, go create a Python folder. Maybe it's in your documents folder. You create a Python folder, and that's where you're going to save your Python programs. You can see I'm already in it. And then I'm going to save this program as hello world.py. The .py is kind of important. It's very important. It tells Thani that that is a Python program. Also, do not put spaces in your file names. If you put spaces in your program names, you can end up in a world of hurt. So do not put spaces in your file names when you save your programs. Okay, let's come up here and run this. So I'm going to run it, and it says hello world. Boom, we just wrote our first Python program. Instead of that, what if I said MSG is equal to hello world. And then what if I came down here and I said print MSG? You guys predict and leave in the chat a comment. What do you think this is going to print? I said MSG is hello world and then print MSG. You guys leave a comment what this is going to print. Okay, and if you said hello world, you would be wrong because it printed MSG. Why? I put MSG in quotes, and so it didn't print the variable MSG, it printed the string MSG. So what we would want to do is come in and say MSG like that, and then we are going to run that, and what do we get? We get hello world. Okay, let's try another program here. Let's say x is equal to 7. Let's say y is equal to 2. Let's say z is equal to x plus y. And then what I'm going to do is I'm going to print z like that. And then what we're going to do is run it, and boom, 9, because z is x plus y, which is 7 plus 2, z is 9. That's really good. Now we can do this a little bit fancier. What we could do is we could come in and we could print the string x plus y equals space, close the string, comma, z. And then if we do that, what we get is x plus y equal 9. It's a little bit nicer formatted. Or we could get even a little bit fancier and we say print the variable x and then print the string space plus space, close the string, and then comma y, and then comma, open the string, space equals space, close the string. And now let's run that. And what we get is 7 plus 2 equals 9. Okay, so that is pretty neat. All right, now how do we do a power? Like if we want to square something or cube something, we could say x is equal to 7, and then we could say y is equal to 7. I want to raise 7 to the power of 2, and I do that by bam, bam. 2 multiplications, like it's 7. The 1 star means times multiplied. 2 stars means raised to the power of 2. And then I'm going to print. I'm going to print y. Okay. And now we run it, and 7 squared is 49. So that worked out. Now, how would we find the square root? Well, let's say that I say x is equal to 25. Now, this is not a Python thing. The Python thing is to raise to a power is a star star. That's a Python thing. That's how you raise 7 raised to the 2 power. But how would you find the square root of 25? Well, the way you would find the square root of 25 is you would say x and then you would say pound, pound. Did I? Let me see. Okay, really, I shouldn't have. I didn't do that right, did I? I should have said that this is x squared like that. Okay, I kind of got a little sloppy there. All right, and when I do that, I get the 49. X is 7 and y is x squared, and I just put 7 in there, which wasn't really very good. So this time, x is going to be 25, and I want the square root of 25. So instead of raising x to the 2, the square root is 1 over 2. So I raise x to the 1 over 2, and then that is going to give me the square root of 25 is 5. Now, what if I wanted to cube something? Let me take the number 3 and I want to raise it to the 3rd power. I want to cube it. 3 times 3 is 9. 9 times 3 is 27. So 3 times 3 times 3, that's 3 raised to the 3rd. And so what I do is I raise it to the 3rd, and then what do I get? 27. Okay, so that is pretty neat. Now, what if I say x is 27, and now I say raise x to the 1 over 3, that's going to take the cube root, and then 27, the cube root of 27 should be 3. And boom, that works really, really good. So all that worked. Okay, let's work a little bit more. So I'm going to say x is equal to 1. That's great. Y is equal to 3. That's great. Z is equal to x divided by y. And then what I'm going to do is I'm going to print the label x divided by y space equals space, close that string, and then I'm going to print z like that. Okay? Okay, x over y is 0.333. Okay, so that is the correct answer, but that's way more precision than we want, especially like if we have a thermometer that's accurate to 1/10 of a degree. It doesn't make sense, like if we converted Fahrenheit to centigrade, to then have an answer that is 27 characters long. So what we want to do is we want to trim that. And the easy way to do that is that we could say z is x divided by y, and then we could say z is equal to round what? Round z to how many decimal places? 2 decimal places. And then what do we have? X over y is equal to 0.33 because I rounded it. I rounded it to 2 places. Now, when you round it, you lose precision. So what I could do is I could say that z, because I might want to use z later on, and I might want that more precise number. So I could say z is equal to x divided by y, which I just did. And then down here, I could say print round of z, round z 2 places. And now z is going to stay, like if I run this, you see, what does it print? It prints 0.33, but if I ask it what is z, z is still 0.333333. Other thing you just notice is when the program stops running, it still remembers all of its variables, right? So I could say what is y? Y is 3. What is x? X is 1. What is z? You see, so after your program stops running, it still remembers what all those values are. Okay, now if I'm so let's say that I have x is equal to 5, and I have y is equal to 17, and then I have z is equal to x times y, and then I'm going to print x times y is equal to, and then z, like that. And now I'm going to run this. So you see, I got a little calculator that'll do multiplication for me. But now how do I get rid of that? Object inspector, I don't want that there. Okay. How do I, you see, the problem is I got a little calculator here, but the problem is I don't want to have to edit the program every time I want to multiply different numbers. So what we want to do is we want to get input from the user. So what I'm going to say is I'm going to say x is equal to input from the user and give them this prompt. Input your first number. And then I'm going to put that. This is what it's going to put out to the screen, the instruction it's going to give out to the screen. I'm going to close that instruction. I'm going to then close that input. And then y is going to be equal to input. And then the string, the prompt is going to be input your second number. And then close the string, that's closing the prompt, and then close the input. And then I'm going to say z is equal to x plus y, and then print x plus y is going to be equal to z. Okay, so I'm going to run this now. And now down here, I get a prompt, input your first number. Well, I want my first number, x, to be 3. Now, input your second number. I want my second number to be 2. Now, I want you to put a comment over in the chat or down below, and I want you to comment, what is the answer going to be here? Okay, what do you predict the answer is going to be? Go ahead, say what you think it is. I'll have a sip of coffee. Okay, so now I'm going to say 3 plus 2 is 32. X plus y is 32. And in this case, it's probably even better just to show it that if I say print the x and then print the plus and then print y and then print the space equal space and then print z. That's even more dramatic, I think, that if I say input your first number 3, input your second number 2, and then 3 plus 2 is 32. Okay, now this is what I warned you about. Did we declare our variables? No, we didn't. And when we did this input function, Python decided, 3, maybe that's a character. I'll make 3 a string. Okay, I will make 3 a string. And then when I input the second number, well, I don't know what he's going to put in. I'll make it a string. So he made x a string and he made y a string. Well, for strings, like if I have the character a, right, and I add to the character a, b, when I do this, okay, the plus is not interpreted like a string plus a string. Python says that doesn't make sense. The plus means concatenate. So what does it give you? It gives you the A concatenated with the B. So what I could say is, like, even what if I said A is equal to hello, okay, and then B is equal to world. Better put a space there, world, okay. And then I say C is equal to A plus B. And then I say, what is C? It's hello world. Because with strings, this plus is not addition. This plus is concatenation. So you see, we were caught completely off guard, and we were told that 3 plus 2 is 32. Well, what do we need to do? I need to take that input, which it inputs as a string, and I need to convert it to an int. And I can do it right here. So it's going to read the 3. It's going to read the 3 as the character 3, and then it's going to convert the character 3 to the number 3. Now I better do that here as well. Like that. Okay. Now let's see if we run it. Okay, so if I say 3, and then I say 2, and 3 plus 2 is 5. Boom, that works very well. But now what if I say 4, and what if I say 2.5? I get an error. Why? It took the 2.5 and then it tried to convert it to an int, and you can't convert a 2.5 to an int. So given you don't know what number people are going to enter, you might better make it a float. Okay, you might better make it a float. Okay. Now, if I say a 3 and a 2, notice 3.0 the float plus 2.0 the float is 5.0 the float. But now come in and watch this. If I say 4 and I say 2.56, it says 4 plus 2.56 is 6.56. And then you end up with this huge long number. And you can also see that we have kind of a floating point error here, because when it does floating point math, it is not always perfect. Now I'm wondering, what if I said 2.0 and I said 4.25, and then it comes out right. So it seems like that error was when I tried to add an int to a float, and it created a float, but then somehow it got a little bit goofed up there. So that's what I'm showing you. In most applications, that error would not matter, but I'm just showing you that you can get in a lot of trouble if you don't keep track of your variables very, very carefully. Okay, so now let's do conditionals. Excuse me. Let's do some conditionals. Okay, so I'm going to say, this time I really do want ints, so I'm going to say int, and I only want one number. So I'm going to input a number, input your number, just ask the user for a number. Okay. Now, what I'm going to show you is how to do a conditional. So it's if, and then I'm going to say if x is greater than 0. Now, if this was Arduino, we would put an open curly and then whatever we wanted as the conditional and a closed curly, and then it would do anything between the two curlies. This would be your clause, the stuff that is included in the things you do, and it could be a lot of different things. You see, you could have many different lines of code, and everything between the curly would be done if the conditional was true. But I think that on Arduino, you got to put it inside of, I think it's a little bit more complicated. Here I say if x is greater than 0, but now I have to put a colon at that conditional. Now notice when I hit enter, it doesn't go back. It comes in indented, and it comes in indented by one tab. So if I backspace, it goes here, and I tab over. Now, what all is going to be included in the if statement? Everything that is tabbed over. Okay, so everything that is tabbed is in the conditional, and then when I stop tabbing, then that is the first line of code after the conditional. So what I could do is if your number is greater than 0, I could print your number is positive. Okay, like that. And then I could say I'm going to not indent anymore. I just have one line of code in my conditional. Now I'm going to say if x is less than 0, then print your number is negative, like that. Okay, and then I am going to just stop it right there. Okay, and now I'm going to run it. Enter your number. I'm going to say 7, and it says your number is positive. And then look, the program stopped. So in Arduino, you have that void loop where it keeps looping. You're not given that free void loop here, but I can create one with a while loop. Now I'll just say while true. When is true true? True is always true. This is going to loop forever, but I've got to create the clause. And so this colon now, it's looking for the indent. And so I've got to indent that. I've got to indent that. Okay, so you see, this is going to loop forever now. So watch this. What is your number? 7. Your number is positive. What is your number? -2. Your number is negative. What is your number? Your number is 8. Okay, now what is the problem with my code? What if I put in 0? Didn't do anything. Why? I did greater than 0 and less than 0, but I didn't completely cover my range. At that point between those conditions, I didn't deal with that. So you got to make sure that you're always fully covering your range. So I'm going to say if x is equal to 0, then I'm going to say print. I don't want to argue whether 0 is positive or negative, so I'm just going to say your number is 0, like that. Okay, and now let's run it. What is that? It doesn't like if x is equal to 0. All right. If you say x equals 0, that's setting x equal to 0. If you want a conditional, what you have to say is x equal. So if x equals 0, that is how you do a conditional. All right. Now, I'm surprised with this. In earlier things that I'd done, it would go ahead and just set x equals 0 and then really confuse you. But now it's actually throwing an error, which is good because it keeps you from getting confused about that. So I say 3, positive, minus 3, negative, 0. Your number is 0. Okay, so that's working really, really good. Okay, now, what if we wanted a compound conditional, more than just one condition? So I could say if x is greater than 0 and, well, let's see, I gotta show you one here. I'm gonna say remainder is equal to x mod, which is the percent 2. And so what the mod does is it divides and tells you the remainder. So if I put in x is 4, this would be 4 divided by 2. The remainder is 0. So the result of this would be 0. Let me see if I can show you that. So let's just say if I say 4 mod 2, 4 mod 2, that's 4 divided by 2 is 2. The remainder is 0. So the answer here is the remainder, which is 0. If I say 3 mod 2, what is it going to be? 0 and remainder 1. Okay. What if I say 7 mod 2? That's going to have a remainder of 1. What if I say 8 mod 2? That's going to have a remainder of 0. All right, so this little mod function allows you to see if a number is positive or negative. What if I wanted to know if it was a multiple of 3? Like, let's say 6 mod 3. If it's a multiple of 3, 6 mod 3 has a remainder of 0. 7 mod 3, that's 7 divided by 3 is 2 with a remainder of 1. And then if I have 8 mod 3, it's a remainder of 2. If I have 9 mod 3, it's a remainder of 0 again. So you see, I'm just trying to show you how the mod works. So up here, I'm going to say the remainder is whatever number you put in mod by 2, and this is going to let me see if the number is even or odd. So if x is greater than 0 and remainder is equal to 0, then your number is positive and even. Okay, and then what I could do is I could take this same code, I could copy it, come here and paste it, and now if x is greater than 0 and the remainder is equal to 1, then it is positive and odd. Okay, and then if x is less than 0 and remainder equals 0, then your number is negative and even. Okay, and now let's take this code, paste it, and if your remainder if x is less than 0 and your remainder is 1, then your number is negative and odd. Now, I don't want to argue about whether 0 is even or odd, so I'm just going to say 0 is 0. All right, so now let's try this. Input your number. 3 is positive and odd. 4 is positive and even. Minus 4 is negative and even. Minus 5 is negative and odd. And 0 is 0. Boom. So, man, we've learned a lot about variables. We've learned about conditionals, if statements, and we have now learned about compound conditionals. And besides and, you could put like an or. And an or means like if if you're if you are a girl or you're wearing an orange shirt, stand up. Well, I would stand up because I have an orange shirt. I'm not a girl, but only one condition needs to be true, okay? But if I say stand up, if you're a girl or you have a blue shirt, I would remain seated because neither one of those is true. So for and to be executed, all the conditions have to be true. If or is used, only one of the conditions has to be true, if that makes sense. Hopefully you guys know the difference between and or. Okay, now let's go in. Let's do some looping here. So I said while true, that loops forever because true is always true. But what if I say x is equal to 0, and then I say while x is less than or equal to 0. And that's what I should say on those earlier conditionals, okay? When I say greater than or less than, you can also say greater than or equal to, or you can say less than or equal to. And so I guess what you have to see is you can say greater than, or you can say greater than, less than, greater than or equal to, less than or equal to, and there's also the not equal to. And the not equal is exclamation. So that would be x is not equal to 0. Okay, x is not equal to 0. So those are the different combinations you can use. And now what I'm just going to say is I'm going to say, let's set x is equal to 10. And then I'm going to say while x is less than or equal to, while x is less than or equal to 10, like that. And now my colon, now notice I'm tabbed in. I'm going to say print x, and then I'm going to say x is, let me start with x is equal to 0. And then I'm going to say x is equal to x plus 1. And then after this, I'm going to say print that's all, folks, like that. All right, now this, if I put it here, every time it would print, 1, that's all, 2, that's all, 3, that's all, because it's in the loop. In fact, let's just look at that. Okay, you see it's like 1, that's all, 2, that's all, 3, that's all. Why? I put it in the loop. But if I take that tab out, it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it'll say one time, that's all, folks. Okay, so you see I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I have that's all, folks. Now, what if I wanted to count negative? Like if I wanted to count down, I would say 10, and then while x is greater than or equal to 0, and then I'm going to print x, and then each time through x is equal to x minus 1. And then here, instead of saying that's all, folks, I'm going to say blast off. Okay, I think that deserves an exclamation point. So now let's watch this. Okay, look at that. We count down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Blast off. Now you could say whether you should count down to 1 and then say blast off, or go to 0 and then say blast off. We could argue about that, but you see programmatically how you can get it to do whatever you want. That is great stuff, okay? Now let's do a simple for loop, okay? You know how to do for loops in Arduino, but let me show you how to do for loops in Python. So I can just say for I, that's my index in, and then I say range, and then range is from 0 to 10 and go in steps of 1. And then what I'm going to do is I'm going to say print x, okay, and then I'm going to say print that's all, folks. Okay, I'm wanting you to get comfortable that anything indented will be included in the for loop, and then when you stop indenting, that will be the first line of code after that. Okay, so let's try that. Before I do, I want you to tell me, predict what this is going to have happen. It's going to count between 0 and what? Okay, let's see. Ooh, what is that? Print. What did I do wrong? Oh, print I, which is the index. Okay, now what is it going to count to? And if you said it would count to 10, you would be wrong because it stopped 1 before 10. And so this is really confusing because you say, like 10, I want it to go to 10. But since it's thinking like an engineer, it says, well, you probably want 10 elements, and therefore, if you start at 0, 9 would be the 10th element. So it's sort of thinking in terms of, that you're going to start at 0. Okay, so if you really wanted to count to 10, you would say, well, let me start at 1, and you go to 11, knowing that it will stop 1 before you want it to, and then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, you hate this until you realize that usually you're starting at 0 and you kind of put 10 and then it stops at 9, which is really where you wanted to, because then you have like 10 numbers in your array, if that makes sense. So hopefully that that sort of makes sense. Now, how would we use this? Let's say I want to input a list of grades. So what I could do is I could say num grades is equal to input, and I better make that an int, right? Input, what prompt do you want? How many grades do you have? Question mark, put a space, close it. All right. Now what I'm going to do, I'm going to say for I in range. I'm going to go from 0 to num grades, and I'm going to jump 1 each time. And then I've got to create my array up here so it knows that I have an array. So I'm just going to create an empty array like that. And so, right, like if I say x like that, okay. Well, I'm sorry. X is equal to an empty array. So I say x is equal to an empty array. And then I say print x, and I just get the empty array. But now notice if I say x dot append, and remember here you use the parentheses, x dot append 23, like that. And then if I print x, I've got 23. And then if I say x append 97, and then I say what is x, you can see that you're building your array. So what you can see is I can build that array. I've got to get the number from the user, so I'm going to say new num is equal to, I want to float it because a grade could be a floating point number. Maybe you make a 97.5. And so I'm going to say input, okay, and then enter your grade, colon, space, close the string, close the input, close the float. Now I'm going to say, why did that? That nonsense doesn't belong there. Okay, now what am I going to do? I'm going to say x dot append. You know what would be better? Instead of calling that x, I'm going to call it grades. Okay. And then I'm going to say grades dot append, and instead of calling this new num, I'm going to call it grade. So I'm inputting the grade, and then I'm going to append the grade to grade. So grade, which is this number I just input, I'm going to append in my grades array. Okay, like that. And then let's say print. Let's say print. Now, grades of I. Grades of I. Okay? And then close it. All right, so now let's see what happens. All right. What is that not like? Oh, int. I forgot to do the int of input. Hopefully you guys caught that. That was kind of a silly mistake. All right. Now, man, I am just so messed up this time, aren't I? Okay, there. That should be right. I'm taking the int of the input. I have 3 grades. I have 97, and then oh yeah, you see what you got to use the square brackets when you're printing or indexing it. Okay, so now how many grades do you have? 3, and then I'm going to say 97, and then it doesn't like that. Because why? I said grades of I, but what did I type grades of 1? And you got to be really careful with that because an L looks like an I and a 1 looks like an I. Or an L really looks like a 1. So like if I made my index L, okay, and then if instead of L here I typed in 1, that really looks right. But then what are you going to get? You're going to get error after error after error, and that 1 really looks like an L. Okay, so you got to watch out for little things like that. But now if we make it an L and an L, and then we come in, how many grades do you have? 3. And then I have 97. I have 92. And then I have 65. Okay, so you see that work. Now let me show you what else you could do. You could take this out, and here you input the grades. But now here, let me talk about one other thing. You say, well, how come it went to num grades? How come you didn't need to say num grades plus 1 so it would go to the end of the list? Because if I have 3 grades, that's 0, 1, 2, and you want to stop at 2. Okay, it's kind of crazy, right? So I don't have to do num grades plus 1 because if I said 3 grades, it's going to take the 0, the 1, and the 2, and then that's going to be the 3. It'll stop where you want it to stop. Okay, so you see it kind of makes sense that it stops 1 before num grades. Did I just confuse you? I hope I didn't. As you start doing this, you can kind of see why they stop 1 before the number that you put in there. And you see here it works perfectly. Now I'm going to say print your grades are. Okay. And notice what I did here. Now I stopped the tab, so this is only going to print once. Now I'm going to say for I in range, and I'm going to go again from 0 to num grades indexing increasing 1 each time. And this time I'm just going to print grades of I. I put a 1 there by accident. Grades of I, like that, and then I'm going to print it. That's all. You know, do you notice something? If you start with the single quote, you can't use an apostrophe. So I got to take that and I could put the double quote, and then that's, now this doesn't goof it up. All folks. Close the double quote, do that. Now let's look at this. Okay, run it. How many grades do you have? 5. I made a 60. I made a 98. I made a 97. I made a 85. And then I made a 96. Okay. And then what does it say? Your grades are, and it gives them in the right order, 60, 98, 97, 85, 96, and then it says, that's all, folks. Okay, guys, so this has been kind of fun. Let's do a little bit more. Okay, let's do a little bit more. I want to show you also that what I could do is I could say that my array is equal to 25, 15, 5, and 0, like that. Now what I could do is I could say for I in my array, and then I could print I, and then I could print that's, same thing. I would say that's all, folks. Like that. Okay. Now watch this. Instead of doing a range, I could just say for I in my array. And what it does is it prints out 25, 15, 5, 0. So you can actually step through an array in a for loop. And let me show you how that's kind of useful. A lot of times you'd be surprised how many times this comes up, but let me see if I could show it to you this way. My fruits are equal to an apple, that's a string, right? A banana, that's a string, an orange, a mango, and a grape. Okay, then I'm going to close that. Then I can say for fruit in my fruits, print fruit. Okay. So you see, I don't have to call this fruit. I could have called it, you know, like screwdrivers, for screwdriver in screwdrivers, but that wouldn't be very descriptive. And just fruits and fruit is just a nomenclature I'm using. You notice that I put this plural here and the plural here, and then I put the singular here and put the singular here. You don't have to do it that way, but it just makes a lot of sense if you do it, because now I'm going to step through singular fruit in a list of fruit to se, okay? And then I'm going to print fruit. So let's watch this. Okay, apple, banana, orange, mango, grape. Okay, that's pretty neat. All right, now what I could do is I could say, I could nest these things for letter in fruit. For letter in fruit, then what I'm going to print. And now I'm afraid all of a sudden, letter, like that. Okay, let's see if that works. This has kind of got me scared. Okay. Oh, don't want that there. Okay, now let's see if this works. Okay, look at this. So APPLEBANAORANGEMANGOGRAPE. So you see the fruit would be apple, and then it steps through each letter in apple. Now this letter isn't important. I could call that J in fruit, and then I could call this J in fruit, and then it would be, Okay, the same thing. So there's nothing magic in that word letter, but it just makes the program make a whole lot of sense when you look at it. And this doesn't have to be fruits. This could be Z, and then this becomes Z, and then this could become for K in Z, and then this would be for J in K, and then print J, and then I get exactly the same thing. But do you see how naming things this way doesn't make a lot of sense? It makes a lot of sense to choose your variable names carefully. So I could call this fruits, just fruits, and then I could say for fruit singular in fruits plural, and then I could say for letter in fruit singular, and then print letter, like that. And this is then, it works. Not only does it work, but it makes sense. And really, so many times when you have a list, it is a list of grades. Okay, so like it would make sense to say this was grades. Okay, grades plural. And then the grades would be 97, 65, 99, 85, 100. And then I could say for grade singular in grades plural, then you can't bust that down further. So I could then just say print grade, like that. Okay, and then you see I get my grades. Hopefully that makes sense. Okay, guys, I need to talk to you about a homework, and I need you guys to just kind of get comfortable with this. And I really showed you how to ask the user for how many grades he has, and then how to input the grades, and then in a separate for loops to print the grades. And so this time, your homework assignment is to do this, but you're going to have 3 for loops. The first for loop is going to input the grades. The second for loop is going to average the grades. And the third for loop is going to print the grades. And then after all of that, you print the average. So input the grades, average the grades, print the grades, and then print the average. That is your homework assignment. And I hope you guys are having as much fun taking these classes as I am having making them. It's at this point I always give you guys that are standing with me on Patreon a shout out. It is your support on Patreon that allows me to continue to produce this fresh quality content every single week. So thank you guys. You can also help the channel by giving me a thumbs up and leaving a comment down below. If you haven't already, subscribe to the channel. When you do, make sure you ring that bell so you'll get notifications when future lessons drop. And most importantly, share this video with other people, because the world needs more people thinking like an engineer and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.